And as I said, I want this to be a little bit informal. I mean, it already kind of was. I just chit-chatted with you guys. But this is a nice time for us to look back at what we've done in the course overall, and indeed then focus on what we covered after the midterm, because that's the material that's going to be included on your final exam. So my plan for today is to do the following. I want to give you an overview of the entire course, what we covered, how things fit together, the chapters that we covered, because I think this is helpful. I mean, even though I'm going to be initially discussing stuff that we did before the midterm, I want you to know that as a course, what you covered has value, even though maybe it's not the most important course that you have to take, depending on your major, right? But still, the reason why we teach 307, even though it's a little bit different from the other courses, is because there are some benefits to knowing this stuff. And so I'm going to give you the overview over the whole course, focus then on the chapters that we covered after the midterm. And then I want to briefly go to the course objectives and learning outcomes that are in the syllabus and show you how we covered all of these things and which chapters sort of tick which boxes, which course objectives. Because I think understanding the why we're taking this course, why did we study these things, is very, very important. Knowing the how, I mean, I'm sure all of you guys know how to do cash flow analysis, how to move payments back and forth. By now, that's kind of easy for you, I hope. That's second nature. But why are we doing this to begin with? I think that's a very important question, because the why enables you to choose or to understand when we should use these techniques. And why did we waste 15 weeks, or not waste, why did we spend 15 weeks learning about them? Okay? After we finish that, hopefully we'll have enough time left to go over one of the quiz problems. And I went through all of them, all of the quizzes that we did after the midterm, and I only found, I remember one problem, I think in the previous, no, not the previous quiz, the one before that. So the quiz on chapter 7, where some of you had some issues with. And it's a very important problem, so I want to make sure to go over that. The rest, I believe, at least looking at them, that they should be fairly straightforward if you have enough time to think about them. But if you have questions, just let me know about any quiz problem that you just don't understand. Most of you generally ask questions right after the quiz, which is fine, and that's better, understanding your mistake and fixing it. But if you do have any other questions, please let me know. I will just go over this one quiz question, and then that will conclude this session. Okay, so let's start. That's kind of the plan. So to start, first of all, I want to talk about what we did do throughout this entire semester. Now, if you look at the textbook, so here are the chapters that we covered, right? I'm just going to write the numbers down. We covered chapter 1, chapter 2, chapter 3, chapter 4. I'm doing this from memory. 5, 6, 7. We skipped 8, and then we covered 9, which is about taxes and depreciation, and then we did 11 and 12, right? So these are the chapters that we covered. But if you look at the textbook, they're organized in the following manner. So chapter 12, along with some other chapters, is by itself in a part of its own, right? Because it's a little bit different from all the other chapters. It's an application of things that we covered, right? Choosing between two alternatives, whether we want to keep the Defender, we want to keep the current machine, or switch to a new machine, a replacement machine, a challenger, right? That's an application, but it's grouped. I forget the name of the part. I can actually look it up. I have the book here, so let me see. But chapter 12 is a little bit different in that regard. Where's replacement analysis? Yeah, so it's a special topics and engineering economics chapter, right? So that's chapter 12. Okay, so let's leave that aside. The other chapters group together kind of nicely, right? We have 3 parts that span or cover the remaining chapters. I'm not sure how many there are. There are 6, there are 7, 8, 9. So there are 9 other chapters that we covered, and they're grouped into 3 parts. 1 through 4 was one part. 5 through 7 was another part, and then 9 and 11 was another part. Okay, so these are the 3 parts, excluding chapter 12, which is special topics. You can think about it that way, right? This part here was about understanding money management. Okay, and here we introduced all of the fundamental concepts that we needed in later chapters, and indeed all of the fundamental concepts in engineering economics in general, right? Remember in chapter 1, I mean, I spent a whole week on chapter 1, again, because I think the context and the why we're studying this course is very important. I'm sure other instructors would just zip through chapter 1 in maybe one lecture or less. But I spent an entire week discussing why, showing you why this course can be useful, at least. If it's not, I mean, it is important, but if it's not important to you, it can be useful maybe. Okay, so remember chapter 1 talked about why we're studying this course. And we said the ultimate goal of studying this course, and as we'll see in the course objectives, is to evaluate alternatives in an economic way, right? We have different engineering options. All of us here are engineers, I think, at least. I think we have some computer science students maybe. But like generally speaking, all of us think like engineers, at least, even if we're not engineers by name. We develop stuff, right? That stuff can be a software, it can be a circuit, it can be a mechanical machine, right? And then we need to compare different alternatives, like which alternative is more economically feasible and which one is more profitable. Which one should I choose? Okay. And again, you can hear from the words why this is an ISE course, more or less. I mean, it can be an economics course, but I mean, economics, they do a lot of optimization and choices between different things. And that's basically what we do at ISE, right? We do choices and optimization. We figure out what is feasible and how to choose the best option that we have available, okay? Chapter 2 was the fundamental chapter, the most important chapter in the entire course. And I told you this from way back when we covered this chapter. If you understand chapter 2, you're good to go pretty much for the rest of the course. You see that the rest of the chapters just introduce some terms, except minus 3 and 4. I mean, 3 and 4 were related to chapter 2 also, but maybe they had some concepts in them. 5, 6, 7, 9, and 11. 9 had a few concepts, right? Depreciation, that's a new concept. Taxes, that's a new concept. But most of the other ones basically heavily relied on chapter 2. And you remember chapter 2, we first of all talked about interest, so here, let me just write down chapter 2. We talked about interest, this I, right, what it is. And firstly, before that even, we talked about the time value of money. That's the most fundamental concept in this entire course. Knowing that money has a time value. Why does money have a time value? Well, because its value reduces over time, and also it can earn more money over time. And so getting something today is not the same, does not have the same value to you as getting that same amount 5 years from now. And then we said we use the interest rate to move payments basically from one time period to another one. Right? And then we talked about all the different series, basically, all the different forms of cash flows. We said we can have a very simple cash flow where we just have one payment, but we can also have an equal payment series, right? Where we use this A given P factor to convert a present value, let's say, to an annual payment series, or it can be P given A. Right? We also talked about linear gradient series and also geometric gradient series, right? And we gave formulae for all of these cases. So that was chapter 2. Chapter 3, what did we do in chapter 3? Well, chapter 3, we talked about the interest rate, right? We said we have the effective interest rate and we have the nominal interest rate. And that's important also for you, right? If you want to take out a loan, next time, look at the statement that you get from the bank and see if you can spot the APR, which is the annual percentage rate, I think. That's what it stands for, right? And then you have to convert it into an effective rate because the compounding period may be different, right? The figure is quoted on an annual basis. They tell you the APR is 24% per year. But then when the frequency at which they compound the interest is maybe monthly. And so you have to do some conversions, and you guys remember the formulas that we use to do that, okay? We also talked about loans, which, as you can see, kind of connects to this topic, right? Because loans are typically where we see these things, right? Because with a loan, you will get an APR that is yearly, but typically the interest is applied monthly in a loan. So this is a very common application of this particular case. So we talked about loans, and we said part of the loan payment goes towards paying the principal, and then part of it goes toward paying the interest on the outstanding balance. Okay, so that was chapter 3. And then chapter 4 was the last chapter in this part. And chapter 4 had to do with actual and constant dollars, right? Which was a little bit of maybe a difficult chapter because it has new concepts and it's not easy sometimes to understand what they mean. But remember, actual dollars is the actual amount, right? The actual bills, dollar bills or Saudi Real bills, banknotes. Whereas constant dollar is measured in terms of a fixed purchasing power, right? With a reference period. So you say I'm going to measure like the cash flow at time period 5 with reference to, let's say, today's constant dollars. So today's purchasing power. All right. That was the first part. And again, those are some fundamental concepts that we need you to understand for the rest of the course, but also just for your general information. Like chapters 3 and 4, we didn't really use them afterwards, right? We didn't really talk about actual and constant dollars. We did not talk about effective and nominal interest rates after that, I don't think. But they're useful for you, at least, and they're important to understand just generally. Okay? Chapters 5 through 7 are very nice because they are very tightly linked together. And I don't remember the title. Let me look it up in the book of this part. It's about evaluating business and engineering assets. So I'm just going to write evaluating. And here's where we get to the core of the course. Remember I told you the course is all about choosing between alternatives. So that's exactly what we did in chapters 5 through 7, right? But we use different criteria in each one, right? So chapter 5, we talked about the present worth criterion. And we said, well, we talked about a number of aspects there. We talked about the MAR, we introduced the MAR, what it means. We had 2 interpretations for the MAR. I may flip to the slides, by the way, for chapters. Well, I'm not going to do chapter 5 because that's part of the midterm, but maybe I'll just go over 6, 7, 9, and 11, and 12 using our actual slides in a minute. So you can stop me when you have questions, and we'll get an overview, a very quick summary of what's covered in each chapter. And I want to focus on those because those are the ones that are included in the final. But for 5, remember we covered the MAR. We said there are 2 interpretations. There's the opportunity cost or the cost of funds interpretation, and then there's the investment pool interpretation. And then we talked about, for all these chapters, we did the following, basically. We looked at the criteria, what it is. What is the net present worth? How do we define it? How do we compute it? What is the annual equivalent worth? How do we define it? How do we compute it? What is the internal rate of return for chapter 7? How do we define it? How do we compute it? And then we looked at, for single projects, how do we evaluate them? Okay, so for chapters 5, 6, and 7, we have a way of evaluating a single project based on that criterion, right? If it's present worth, we said if the present worth is positive, we accept, negative, we reject, 0, we're indifferent. Similar thing for the AE. And then for chapter 7, we talked about IRR and the MAR. How do they compare? So if the MAR is less than the internal rate of return, then I accept, right? If it's equal, I'm indifferent. If it's the opposite, if the MAR is greater than the IRR, then I will reject this single investment. And then at the very end of each chapter, right, we talked about how to compare alternatives. So in chapter 5, we compared alternatives using the present worth value, the present worth criteria. Chapter 6, we used the AE to compare mutually exclusive alternatives. And chapter 7, we used the IRR criteria. But remember in chapter 7, and I'll show this when I go over the slides, we had to do incremental analysis. Okay? So that's a nice group of chapters. And once you've seen one of them, you've kind of seen them all. You just have to update basically the answer to all these questions. What is the criteria? How do I compute it? How do I use it to evaluate single projects? And how do I use it to evaluate mutually exclusive alternatives? And we also use them, by the way, to look at infinite horizon projects where you can repeat things in cycles. And that we covered in all of these chapters. 9 and 11 together are in a part of their own, I think. Maybe there's an additional chapter. I think 10, of course, has to be included at the very least, right? And this is about coming up with cash flows, right? So in all of the previous chapters, you were given cash flows, and everything was nice. In chapter 2, you were just given a cash flow. Chapters 5 through 7, you were given a cash flow for a project, and that's it. You could just use it directly. But in chapters 9 and 11, we actually say, hang on a minute, that cash flow, I need you to come up with it, right? And to do that, you have to know all of the sources of income that your project has, right? Your price, how many units are you expected to sell, etc. all your expenses, what is the operating cost, the maintenance cost, any leasing fees, variable cost, fixed cost, all of that information. I have to put that together. But I also have to include taxes, which is a thing in the US at least. So in the US, taxes are important. And all of the cash flows that you were given here in these early chapters were generally after-tax cash flows. And so first you have to take your income, subtract your expenses from your income. But remember, we talked about, in chapter 9, we talked about depreciation, which is an important thing in computing taxes. So in order to find the taxes, I have to take a step back and compute the depreciation for my assets first, because taxes is all about accounting. And in accounting, that's how they do things. They take the cost of the asset and they divide it up over time periods. Okay, so they say, I'm not going to include the 1 million that I used to purchase this machine today at year 0 or at year 1. What I'm going to do is I'm going to distribute that cost somehow using one of 3 or 4 techniques that we learned over the lifetime of that asset, be it 5 years, 7 years, whatever. Then I'm going to include depreciation as part of my expenses, subtract my expenses from my income, get my taxable income. Then I need to find my tax, right? Then I need to subtract my tax from my taxable income. Then I get my net income, okay? So before I get my cash flow, I get the net income, which is basically my income, including or having depreciation subtracted from it, right? Along with the expenses, minus all the taxes. That's my net income. But it's not quite a cash flow, because remember, when we include depreciation, it's not a real cash flow, right? It's just an accounting thing that we do. And so I need to convert this net income into cash flows, right, into CFs. And we said the way we do that is, remember, I mean, you guys are doing this probably right now in the homework. You have to include things like the gains tax, if there is any. You have to include the salvage value. And you also have to include the investment cost of the machine. Now you put that cost in year 0 today. You put that minus 1 million that I gave in my example in year 0. And then at the very end, you get your cash flow from 0 all the way to whatever, 5, 6, 7. Now you can go back to the techniques that we've learned and do all of your analysis on that. Okay, so that's chapter 9, more or less, and also chapter 11. But in 11, we also introduced the uncertainty part. We said maybe your estimates are uncertain in coming up with these cash flows, and so maybe you need to do some analysis to present a better picture to management, let's say. If we continue chapter 11 all the way to its end, I think we're going to tell you how to choose or how to handle the uncertainty better. Right now, we're just saying, oh, you do sensitivity analysis by changing the value of one variable and seeing what the net present worth is. But we're not telling you what to do with that, really. You just present it to management, let's say. Okay, but this is also, chapter 11 is also related to cash flows and how you come up with the estimates for your cash flows. And then chapter 12, finally, that's what we finished a couple of classes ago, was about replacing machines. And I already kind of gave a brief introduction to that when I started circling this chapter, when I talked about it at the beginning, right? It's just about whether or not you want to replace a machine now or you want to replace it in the future. And mostly, I mean, we did some examples, but we also introduced some terminology, right? Defender, challenger, economic service life, etc. And let's go over this together in a little bit more detail. So let me stop sharing this set of slides, and let me pull up the slides for chapter 6. And let's just briefly go over chapter 6 and see what we covered in that chapter. We can hit the main points. So yeah, I guess I can use, no, okay. Yeah, I'll just use this version here. Okay. Oh, it's not letting me share. Let's try that again. There we go. Okay. So chapter 6 was about the annual equivalence analysis, AE, right? That's how I normally refer to it. And let's see. Let's look at the objectives, and that will basically summarize what we need to know. And that will give us a good idea of the topics that we covered. And then we'll just go over them very quickly, and you can stop me if you have questions. So here we need to understand, again, the questions for these chapters, 5, 6, and 7, is to understand what we're doing. What is AE? What is this criterion that we're using? In AE in particular, we talked about decomposing. So we said sometimes when we just have costs, we have this AEC value, right? And generally, sometimes you have cash flows that look like this. You have an investment, you have a bunch of operating costs, and then you have a salvage value maybe at the end. Maybe, I mean, there's an operating cost here and then the salvage value. And since here mostly what we have is our costs, you can decompose the total annual equivalent cost, the AEC, to two parts. We said we have a capital recovery cost, and we said we have operating costs. Okay, and then we can compute this part here using a formula. And this part generally is given as annual, which is nice, but sometimes you may have fluctuating operating costs over the years. And so you have to find the present worth and then convert that back into annual so that you get an equal payment series. Okay, but this also you're doing in your homework, most likely. So you don't have to, I think, do this all the time. You could just compute the AEC the old way, right, which is moving all the payments back to time zero and then finding the annual equivalent cost. That's fine too. But here we introduce these two concepts, right, the capital recovery cost, CR, and the operating costs. And we also, if you guys remember, in this chapter, one of the important things that we did is to find the per unit cost or per unit savings, right? If I tell you a machine has been used 3,000 hours per year, I can find the AEC and then I can divide by the number of hours per year to find sort of the per hour savings or the per hour cost for operating that machine. You can also find per ticket prices, let's say. I mean, that's an example I think that we've seen in the homework, right? It's just a per unit cost for applications. And then we looked at make or buy decisions, which are very common in AE. We said because the costs for purchasing items are generally given as annual, as per unit costs, right? Which you can convert sort of in the opposite way. I mean, here I take the AEC, I divide it by the number of hours or the number of units, right? And I get the cost per unit. Here, if the cost is given to me per unit, I can convert it into annual by multiplying by the number of units, right? In the make or buy decisions. And that's why this is a nice application for these AE techniques. And finally, again, we compare mutually exclusive alternatives using AE. So let's go over the chapter very quickly, just to see what are the important points here. Here are the applications. Okay, so here's one way we can compute the AE, which is finding the present value of a cash flow, right? I take all of these payments here, move them back to zero, get the present worth, and then I use my A given P factor to convert it back into annual. Or not back into annual, but to convert it into annual, right? And I get an equal payment series that starts at time period 1 all the way to the end. And that is my equivalent annual cash flow. Okay? And the value of this arrow is going to be my AE. So this is one way of doing the computations. Right? What else did we cover? Yeah, so this is what I just said. And we said this is a consistent criteria with the net present worth criterion. And in order to evaluate single projects, right, it's very similar to the net present worth criterion because I mean it follows from the formula if you think about it, right? If this is positive, this has to be positive in order for me to accept, right? And so that's what you see here. If the AE is positive, you accept. If it's 0, you are indifferent. If it's negative, you reject. And then we're going to talk about comparing mutually exclusive alternatives a little bit later. Right? And so here, again, you can find the AE by converting from the net present worth. So you find the net present worth first, and then you convert it into annual. That's one way of doing things. And you can look at the example for more details. This whole thing is just doing that. Yeah, this is telling you where AE is useful. And remember, I just told you in the objectives, like we have make or buy decisions. It's very useful there. It's very useful when you want to find unit costs or profits. It's also useful generally when you have yearly or annual reports in real life. Right? And we talked about this repeating cash flows cycles. So one of the nice applications of AE and why it's so useful is that if you have an infinite planning horizon, right, where you can repeat the project with identically the same cash flow, you guys see here, this cash flow is exactly the same as this cash flow. Right, we're just repeating it. The AE of the entire thing, right, all the way to infinity, is the same thing. So I'm just going to write AE infinity to denote the AE of the entire thing. If I wanted to convert this infinite cash flow to an annual equal payment series, it is the same as the AE of a single cycle. Okay, so this sub C here just means the AE of a single cycle. So if I compute the AE for this cycle, it's going to be equal to the AE for all of them, for the whole thing, right? That's a very, very nice property, and it makes life very easy for us when we have infinite horizon projects where we can repeat stuff. And here's verification for that. Then we talked about the capital costs and operating costs. And we said capital costs are associated with owning a machine. So that includes things like I and S, right? Generally, it looks like this for capital costs, right? You just consider I and S, and there's a formula that converts I and S both into annual. And that is a very nice and handy formula. Hopefully you've all memorized that by now. I don't think you need the formula sheet for it. I'm going to show you that formula on the next slide. And then operating costs, which are just the cost of operating a machine, right? Annual cost of operating a machine, but they may differ from year to year. In that case, you still have to do the conversion, right? Convert it into present worth and then back into annual so that you have an equal payment series. So this is what the capital cost formula looks like. I minus S, A given P, plus IS. Right? And here's how you derive it. And we've seen an example on this. I'm going very fast here just because I want to touch on the main points of this chapter just to refresh your memory. I don't want to spend too much time talking about things. What is this example about? Oh, it's about justifying a project with the AE method. Right, so you want to compute the AE for this project, and you can do that using you can do it using the other way, which is finding the present worth and then converting everything into annual. But you can also just compute the capital costs, compute the operating costs, which are given, I think, as 33,000 maybe. Yes. Well, it's operating savings in this case, not cost, but I mean the principle is the same. It's just the sign that changes. And then you add the two together, that gives you the AE, right? So AE is equal to the AE of the capital recovery cost. I mean, you can write it like this if you want to. I mean, capital recovery cost is an AE, okay? But I'm just writing it like this for emphasis. And the AE of the operating cost, right? So you can do this one first, and then add them together or subtract them. Just be careful with the signs if it's savings, not a cost, right? And that gives you the annual equivalent cost. And we've seen a couple of examples. I'm not going to go through these. Yeah, and here we saw some applications where we do unit cost or unit profit calculations. And we said first we have to find the number of units that we want to produce over the lifetime of the asset, identify the cash flow series, compute the present worth of the project's cash flow series, and find the AE. And then we need to basically divide by the number of units. So that should be easy. The only case that maybe is worth talking about is this case here. No, this one here. The number of units changes from year to year. There's an additional step that you want to have, right? And that step is you have to convert this operating profile, in this case, notice here the number of hours changes from year to year. So the way we did it in this case is to do the following. You take your original cash flow, which is given here somewhere in the problem, this original cash flow, and you find the AE for this cash flow, right? You can call this 1. That's the first part of solving the problem. Then you go back to the operating profile, which varies from year to year, right? And you construct a cash flow using that operating profile. You say in year 1, I think this was it savings? No, this is cost, I think. No, it's savings, right? It says savings here. Okay, so this arrow should point up. The first year, it's 1,500 hours, right? And the second year, it's 2,500 hours, and so on. But you can multiply, in order to convert this into a savings, you multiply by some unknown per unit savings value C, right? Savings per machine hour. So if you operated 1,500 hours times C, which is the savings per machine hour, right? That gives you the total savings in that year. Then you to convert this cash flow into an annual equivalent cash flow, right? Find the AE for this one, and that's going to be your 2. Then you're going to set 1 and 2 to be equal and 2 here, as you can see, is going to be a function of c, right? You're going to multiply all of these guys by c. And then you can set them to be equal and solve for c, and that gives you your answer. That gives you the savings per operating hour in this case, where the number of hours, let's say, fluctuates or changes from year to year. Okay, so make sure you understand this point. Go over it later, but this is also a key point in this chapter. And then we talked about the make or buy decisions, and those are hopefully easy. You just construct the cash flows, and then you make a comparison and choose the one with the cheaper cost, let's say, right? Life cycle cost analysis, again, this is just comparing mutually exclusive alternatives. What else is important here? And here we talk about the cycles, which I already mentioned, right? The cycle structure is very nice if you have an infinite planning horizon, because the AE of the whole thing is equal to the AE of the cycle. And that makes our life very easy, and we can compare things just by finding the AE of the first cycle for each of the 2 alternatives, right? So I can find the AE of this guy, find the AE of this guy, and I can compare them very easily when I have an infinite planning horizon. Okay, and then we have 2 more practice problems, and that concludes this chapter. So those are kind of the key things in this chapter. Any questions on chapter 6 before I move on? Okay, let's go to
all clear.
I want to make sure. Oh, I'm sorry? All clear.
I'm saying all clear until now. I think
okay, that's good.
The complicated part starts from 9 and above. Also 9
I agree.
It's not as tough as 11, 12.
Yeah, I agree. Someone had a question, I think.
Yes, in chapter 6, when do we
Yes.
repeat the cycle? I didn't understand it.
Oh, so let me.
It was on slide 19, maybe.
So you repeat if the problem tells you to repeat, basically. Maybe you mean this one. So let me just reshare. I mean, generally these problems have the following form. They will. The problem will say. So let me just share again. Right, the problem will say something like, okay, there we go. It will say something like, suppose. Let me actually go to the example at the very end because it does the same thing, but it starts off like this. It says, suppose you have 2 alternatives. One has a lifetime or a project life of 3. One has a project life of 5. But the question will also say that the required service period, the length of time you need these projects in place for, is indefinite. It's infinite. It's very long, right? So I'm going to keep replacing, basically, and the question should specify this. It should tell you that you're able to replace this model with the same model at the end of its life, right, at this time point here, with the same exact costs and benefits. So if the problem says that, if the problem says the required service period is infinite or indefinite, and you can replace the models identically always, right, with the same cash flow, then you can repeat the cycles. Then that means I can, in order to fill out an infinite horizon, how should you do that? Well, you should take this cash flow and repeat it an infinite number of times, right? Take this cash flow and repeat it an infinite number of times. Okay, so that's when you should repeat. And then we said, because AE has a nice property, if you want to find the AE of this infinite cash flow, you only need to find the AE of a single cycle. And then you can use that to compare because they are the same. The AE of a single cycle is equal to the AE of the infinite horizon. Hopefully that answers your question.
Yes.
Okay, yeah. So questions should tell you, basically the key things are indefinite and you can repeat. Once you see those 2 assumptions, then that means you have this structure, right? You have the infinite cyclical repeating thing. Okay, so let me go over chapter 7. I want to be sure to get to chapter 9 because I'm sure, hopefully 11 is easy. I don't need to go over it. Maybe I could skip it in the interest of time. But 9 I want to get to, so let me go over 11 fairly quickly. So let me just pull that up. Okay. I also want to be sure to have time at the end for the quiz problem. So I may need to go over even faster on chapter 7. Oh, did I not share? Okay, there we go. So chapter 7, we use the rate of return or the internal rate of return criteria. Again, we need to define what we're using. How do we compute it? How do we use it to compare amongst alternatives, right? And that's basically what these objectives are saying, more or less. But we first, if you guys remember, introduced a bunch of definitions for the rate of return, like what is the rate of return? And we said the reason why we use it is because it's maybe more easier to understand. When I tell you that the rate of return on something is 15%, it immediately gives you, it's more intuitive, let's put it that way. Right? And these are the sections. So these are the important things that we cover. What is the rate of return? How do we compute it? How do we use it to compare or to evaluate single projects? And then how do we use it to compare mutually exclusive alternatives? So I won't go over the definitions. You can go over those in your own time if you want to while you're studying. But really the key thing is, again, I mean, the definitions answer what it is, but I'll just skip that. Hopefully you guys remember what it is. And we had 3 definitions for it, I think, depending on the perspective that you take, whether it's a loan, it's a project, etc. One of the key things that we talked about here is the types of investments that we have, the types of cash flows. We have simple investments and non-simple investments. What was the difference again between these two?
Multiple sign changes in the non-simple and one sign change in the simple investment.
Exactly. What do we do about zeros?
I think we ignore them.
Yes. So this here is
a question on this one.
Yes.
Is simple borrowing one of the types of the investment, or is it a different thing? Because sometimes it asks about the type of the investment, and I don't know if I saw a borrowing one, should I consider it as a simple investment or ignore it?
Well, I think like by definition, like if I'm being any precise, it's not an investment, right? It's borrowing because it's not. I mean, it's a negative investment if you see what I mean, right? It doesn't follow because investment usually has an arrow going down at the beginning and then maybe an arrow going up at the end or something, right? Or a bunch of arrows going up. But with borrowing, it's the opposite, right? You're taking money right now, so you're not investing, and so that's why I think it's a separate thing. But really depends on who's writing the question. But I would say, like from my perspective, treat it as a different thing, completely. Like it's simple,
yeah,
but it's not an investment.
Yeah. Because I saw one example, someone sent it on the group once. It gave you different cash flows and says classify by a simple investment or non-simple. One of them was borrowing. So he was asking, should I consider this as a simple investment or ignore it completely?
I would ignore it myself.
Okay.
But again, I mean, the thing here is it depends. Hopefully, it's not the only one, right? Maybe there are other simple investments, but
yeah.
So the question is asking you like go one by one and classify them, right?
Yeah.
Okay. Yeah, in that case, I would ignore it, I think. But you can always ask like just to be sure in an exam if you face this question. But from my perspective, for my own things, I don't think I gave you a simple borrowing question in the homeworks or the quizzes. But if it did come up, I would just ignore it. Treat it as a separate thing. Like here, we're only talking about investments. So initial one is negative. And you guys remember from the definition, actually, just to be precise, let me show you the definitions.
Yeah,
simple
investments negative.
Exactly. Initial cash flows are negative. So that's one criteria. So if you see a simple borrowing one, that doesn't fit that criterion, so you should ignore it. It's not a simple investment, right?
Okay, thank you.
So the initial cash flows are negative. Yes, you're welcome. And there's only one sign change, right? So it's negative. Maybe there's a zero. Again, that's fine. Zeros we ignore. Maybe it's still negative here, but then it switches to positive and stays positive, right? So that's a simple investment. With a non-simple one, the sign changes, right? Or changes multiple times, right? So you have negative, positive, negative. That's already a non-simple investment. We ignore zeros. And so here we looked at examples and graphs. These have properties. We'll get to them in a moment. Then we talked about how to compute the IRR. And we said we can only, I mean, unfortunately, we have to solve a complicated equation sometimes. So we can't always do that by hand. And so for most of the time, we use software. However, for the exam, I expect you to be able to do these two approaches. Either you solve it using the quadratic formula, for example, if you have a square term, right? You guys remember 1 plus I to the power 2. If you're moving a payment 2 time periods back, let's say, you're going to have a term like this, or to the minus 2, right? Or the trial and error approach where we did interpolation, right? And so hopefully you remember what those are, and you guys can do that. So interpolation was or the trial and error approach was sort of an iterative approach where you iterate. You start from a guess, and then you see what the present value is at that guess, and then you need to adjust your I based on that guess. And you could be smarter about how you choose the next I by doing interpolation. If you bracket the solution, right? If you have one value on one end, one value on the other end, one is positive, this is positive, one is negative, then you know, remember, so this is kind of important, the internal rate of return solves this equation, right? Yeah, this is what you need to solve to find the rate of return, I star, or I. No, it's I star, but remember, depending on whether the investment is simple or non-simple, the I star can be equal to the internal rate of return, or it may not be equal to the internal rate of return. Okay, so that's coming, I think. I think we have a flow chart for that. And so these are the approaches. I'll skip over them very quickly. Let's not waste too much time. Here's the criteria for single investments. If the IRR is greater than the MAR, or the MAR is less than the IRR, right? I'm just saying it the other way around. Then you accept the project. If it's 0, you're indifferent. If it's negative, you reject. So this looks a little bit different from AE and PW, right? There was just about being positive. Here it's about where the two values are in relation to each other. Right, here's the flow chart that I was talking about. For a single project, you first need to look at if it's a simple investment or if it's a non-simple investment. If it's simple, what do we know about simple investments? In terms of the number of possible I star values. How many do we have?
What's the question again?
So how many I star values do we have in simple investments?
It's 1. And the non-simple you may have varies, it varies sometimes.
Exactly. So for simple investments, we can be sure that we only have one unique rate of return, and therefore it is equal to the IRR, which is the rate of return that I should use to evaluate, right, to compare it to the MAR and then evaluate the acceptability of the project. For a non-simple investment, generally may not be the case, right? You may have a unique I star, it may happen, or you may have multiple. But remember what I said in Appendix 7A, it says that even if you have a unique value in the non-simple case, it's not a guarantee that you can use this criteria. There's an additional condition that we didn't teach you that you have to check. So if you see a non-simple investment, you can just assume that I can't use IRR. I will abandon that approach and I will use the net present worth criteria. So I will go back to chapter 5 in this case. Question, yes, Khalid.
دكتور، مرات إذا حليت بالاي ار ار أقدر أتأكد من إجابتي إذا كان مثلا أختار مشروع بناء على ربحيته بالاي ار ار كرايتيريا، أقدر أتأكد بإجابتي عن طريق النت بريزنت وورث. هل تعطيني تأكيد الإجابة ولا ما تأثر إذا قال لي اختار عن طريق الاي ار ار؟
I mean, it's good for you to, as a check, yes, definitely you can do that, especially for single projects. Just to be sure, you can evaluate the present worth and see if it's positive. But it will only, it will only say something about the final answer, whether to accept, reject, or being indifferent, right? Because hopefully you see what I'm saying. If your MAR, let's say, is less than your IRR, right? In that case, we accept, right? So just to be sure that your accept decision is correct, you can definitely evaluate the present worth at the MAR and see if that's positive. You may make a mistake here, of course. The number may be different, but if your number is still positive, and hopefully you computed it correctly, it will be consistent with this decision. You see that here, right? These two are consistent. So using PW and using IRR, they're consistent. So if you want an additional check, then absolutely you can do that.
Okay, thank you. بس دكتور مرات يعني
Yeah.
يجي يقول لي اختار بين A و B two project مو بس accept ولا reject choose between A or B يعني
That's
مرات
more difficult.
اي اذا كان صعب بالسولوشن بالاي ار ار او مثلا اعتبر اني لخبطت فيه هل ممكن اجيب من نت بريزرفورت الثنتين واقول له خذ هذا ولا بيقول لي لا انا طلبتها منك اي ار ار انها تتغير؟
They should be consistent. Of course, if it's multiple choice, I don't need to see your answer, so you can do it however you want. Generally, I think we're going to try to avoid that. So we will try to force you maybe somehow to use the IRR.
Okay.
But you could definitely use present worth, I think, in most of the cases, and it should be consistent. I don't see why it should give you a different answer.
Okay, thank you.
You're welcome. Because remember, also for non-simple cases, you're going to see at the end of this chapter, when we actually compare two alternatives, we have a non-simple investment. The incremental investment is non-simple. So we actually cannot use IRR, right? We actually have to use the net present worth. And so we're going to go back to the first two alternatives and find the net present worth of them and then just choose based on that. Okay? So we'll see that later. So the two are consistent with each other. They should be always, I think. So for mutually exclusive projects, which is the second part, we have to do something called incremental analysis. And there I'll just show you later what we need to do. Right, so this is for a single project, blah, blah, blah. So let's go to, right, and this is showing you a problem in action. How do we solve for I? Right, so here's mutually exclusive alternatives. We talked about why we need that, which is not really, which is good for understanding, but let's go to maybe a problem or the steps, yeah. So first of all, we need to subtract one of the two cash flows from the other one, if we have two. And the way we do it is we want to subtract in such a way that the first value is negative in my difference cash flow, right? And so that's why I subtract the cash flow of the lower investment project from the cash flow or from the cost of the higher investment project. And that gives me, in this case, for example, B minus A. I find the IRR of this incremental investment, and then I compare that to the MAR. If the IRR of the incremental investment is greater than the MAR, so if the IRR of B minus A is greater than the MAR, I'm going to choose the first one, which is B. I'm going to select project B. If it's equal, I'm indifferent. If it's the opposite, if it's less than the MAR, I'm going to choose project A. An important thing here to note is that you have to make sure that both IRRs for the individual projects are greater than the MAR to begin with. Because if not, I can exclude the project that does not satisfy this criteria from further analysis. Right? And that makes my job very easy in that case, especially if I have two, right? But one of them does not have an IRR that is greater than the MAR, then that project is not a profitable project anyway. So you can just cross it out, eliminate it. And therefore, you're going to choose project B as long as its IRR is greater than the MAR. And actually, the quiz question that I wanted to talk about relates to this. I'm not sure if I'm going to have time to go over it, though. We'll see. Right, and so here are a couple of examples, right? You subtract again to get the first one negative, find the IRR of this, and then compare that to the MAR, right? And that's how you make a decision about which project to choose. Remember what I told you before, if the initial cash flows are both the same, if you subtract, you get a 0, right? The way we do these problems is we look at the next cash flow, so at time period 1, and see how we can get a negative if we can. And here, obviously, if I do C1 minus C2, I'm going to get a negative value at the beginning, right? And so that's what I do. So that's another thing that you should be aware of, right? So here you see I get a 0 when I do C1 minus C2, but here I get an initial negative value. And then I proceed exactly as before. What do we do if we have 3 alternatives? Well, we do tournaments, right? We do brackets. So we start with the two lowest. Is it lowest, I think? Yeah, so we start with the two lowest and second lowest projects. Compare those two, choose a winner, and the winner faces off against the remaining one, which is D3. So you go sort of in successive steps. Okay. I think this is the one I'm referring to, Khalid. So here you see I have 2 projects. I need to compare them. First of all, I need to find the least common multiple because they have unequal service lives. So here the least common multiple of 2 and 3 is 6. I develop my cash flow, right? Look at what happens with the incremental cash flow, right? So this is B minus A. I get a negative value, but here all of a sudden I have lots of sign changes. And for this, I don't know how to do this. I don't know how to find the IRR for a non-simple investment, because remember we have multiple routes and we don't know which one to pick as the IRR, because the criteria is just about comparing IRR and MAR. So it's just about comparing these two values. So I need one value here, but if I have multiple routes, I don't know which one to pick to compare it to the MAR, right? And so in that case, I'm going to abandon using incremental analysis. I'm going to go back to just finding the present worths of these guys, which is what you see here, right? And that gives you a correct answer. That's fine. And in fact, in this case, the additional criterion that I talked about, right? So this non-simple cash flow actually has a unique rate of return, and it actually satisfies the condition that I didn't talk about, which is in chapter 7a in the appendix, which we don't cover, right? And so in this case, you can actually find the root, find the I star, and that's going to be equal to your to your internal rate of return, and it gives you a consistent decision, right? So I think I write that here maybe. So yeah, even though B minus A is non-simple, it does have a unique rate of return, and it is a pure investment, which is in chapter 7a. So you can use IRR here, and you can select B. If you look at the present values of A and B, right? Let's see what we get. So here, actually, they looked at the present values of the difference, which is also fine. I mean, you can do it either way. There are multiple ways to do this, right? You can look at the present value of A, look at the present value of B, compare them. You can look at the present value of B minus A, see if it's positive. In fact, that's the same thing. You can write down the expressions and see that these things are related, right? So here we have the present value of A, the present value of B. See how the present value of B minus A relates to the present value of B and the present value of A. You'll find a very nice simple relationship. Okay, so that's why these two things are equivalent. Or you can use the IRR criterion only because the two conditions are satisfied in this case. This you can actually ignore because we don't cover this in detail, but I'm just writing this as an FYI. Okay? Yes, Khalid?
يعني دكتور لو مثلا فرضنا السؤال هذا جاني بالفاينل، بدل لا اجيب البريزنت وورث حق A وحقة B بعد اقدر اجيب B ماينس A واطلع بريزنت وورث اذا هو greater than 0 اقول choose B. هذه يعني نفس IRR ينطبق على البريزنت وورث.
Exactly.
اوكي.
Yes.
Yeah.
So these are three ways to solve the problem, right? One way is finding them individually. One way is doing this, and the third way is doing what I described here, which we actually don't know how to do. Okay, so this one you can ignore. The third way in this case you can completely ignore. And so we have these two ways, and these two ways are it's very easy to see that they're exactly the same mathematically. I mean, if you just write down what the expressions look like, compare them, you will see a very nice relationship. In fact, I think you will just see that the present worth of B minus A is equal to the present worth of B minus the present worth of A. Okay, and so if this is positive, that means that the present worth of B is greater than the present worth of A. So hopefully you see what I'm saying here, right?
Yeah, it's clear. Thank you.
Which, I mean, so it's exactly the same. So you can do it in whatever way you want, which is nice. Yeah, and that's it for chapter 7. So let me start chapter 9. Any other questions on this chapter before I move on? Okay, I'm sure all of you want to get to 9. So let's do that. And hopefully I have at least 5 minutes at the end for my quiz question. Since I think it's important, and a lot of people struggled with it, I want to make sure to go over it. So let's do 9 first, and hopefully we don't spend too much time doing 9. I think Muhammad has questions or issues with chapter 9. So Muhammad, can you let me know maybe right now which sections you have an issue with, so I can spend maybe more time on those and go through the other parts fairly quickly?
Okay.
If you are there.
Yes, I'm
yes.
Just give me a minute to open the note.
Oh, okay. And guys, also if you do have issues with this chapter in particular parts, let me know what those parts are so I can maybe just skip to them directly just to save time. Because I want to be sure to address your concerns, especially with this chapter. But unfortunately, I don't think I have time to go over the whole thing. Yes, Badr?
Yeah, trade in. I have a small issue with it.
Trade in. Is that in this chapter?
Yes, chapter 9.
Which slide maybe, or which?
Uh,
'Cause I don't remember trade in discussed here, but maybe. Oh, I see. This one?
yes.
Okay, so let me start with this one.
Okay.
Yeah, go ahead, sorry.
In the quiz, there is a trade-in question also.
Let me see. I don't remember that one, honestly. So, yes.
The part that above book depreciation.
Book depreciation?
After that.
After that, so starting. Okay, so starting from, come on. From here?
Yes.
Okay, so I'll focus on the taxes maybe then and skip depreciation. So I'll just say one note about depreciation, and I'll talk about Bedr's question, and then I don't remember the quiz question because I mean that may be a bad sign, because if it had a trade-in, I just want to be sure I. Oh. Yeah, no, the question may be fine. I'll have to look into it later. But in any case, so for trade-in, generally at least, so depreciation, of course, let me just say one or two sentences about why we need this chapter, and then I'll go through whether it's example or question about trade-in, and then I lost the question, and then I'll talk about taxes. So question is here. Okay. So depreciation, we need this, of course, to compute taxes. And again, taxes, we need them to compute the cash flows, right? And the way we do depreciation is using one of three methods, which hopefully, I mean, they're very easy for all of you. We just need to allocate the cost basis, which remember is the total cost of purchasing a machine or an asset, plus the cost of installation, shipping, etc., all the associated costs. And then we allocate that over a number of years, right? Somehow, using one of the three approaches. For trade-in value, I mean, the only note here in this example, and this is where I want to make sure that the quiz question does this correctly. The only note here is that the cost basis, if you have a trade-in, is equal to the cash paid plus the book value. Right? And so here, let's look at this example. You're giving back an old car to buy a new car, right? And so the new car has $30,000 as a price tag. The old car has a net book value of $5,000. But the dealer says, if you give me your old car, I will give you $6,000 in trade-in allowance. Okay, so the $6,000 is the trade-in allowance, or the trade-in value of this old car. And therefore, it reduces the price that you pay by $6,000. And so that's why you only pay $24,000. But in this case, as I was saying, the only new thing is that the cost basis is equal to the cash paid, so this $24,000, plus the book value. That's how you find the cost basis when you have a trade-in scenario. So you take the book value, and the book value is $5,000. You add the two together, and that gives you $29,000. And that's it. And then you can proceed as before, right? You compute the depreciation as before. It's just finding the cost basis is a little bit different. In the quiz question, I actually think you don't need to do that. I don't want to waste too much time. Go ahead. Yes.
In the quiz, I think you have just calculate the book value depending on the double declining balance method and subtract the two values.
Yeah, exactly. Yes, I just want to see if like. Yeah, I think that's what you need to do, because there's no way to do what we just described in the slides. Yeah, so but for the quiz, you have the 42,000. Right?
Yeah,
just take that. Yeah, go ahead.
In the quiz, it was clear, but when I see the concept of trading and the quiz, I couldn't make sure I understand trading.
Okay. Well, here, I
Yeah,
mean,
so
maybe I
weird.
could
And I
have.
also get it wrong because of that. I thought when I saw trade in, I thought it's a trade in problem. So I got lost in that case.
Yeah, but I don't think like I'm thinking even if you wanted to do what we did on this slide just here, to find the cost basis, you need to take the cash paid, which is not really given. I mean, this is a different problem. I think the one that's in the quiz. So it should be as straightforward as computing the book value and then just subtracting the book value from the trade-in value. I mean, I could have replaced trade-in value with something else, right? It's just sold for $16,000. Maybe I didn't think about trade-in value. That's why when he told me there's a trade-in question, I didn't remember it because I mean, this to me was not meant to be a trade-in question. It's just meant to be a selling price, right? Some value that you're getting for that asset, $16,000. So hopefully, at least the solution to this is clear, and the point that this slide is making is clear. Especially if you're given more information about what the actual price of the car was, the 30,000 in this case, what you actually paid because of the difference between the two, right, which is 24,000. Then, if you want to find the cost basis, you need to do what's described here in this slide, taking the cash paid and adding in the book value. In the quiz problem, I didn't even give you a lot of this information, so you can't really treat it as this sort of problem here. Okay, hopefully, I'm not sure if I answered or addressed your concern better, but hopefully at least now it's a little bit more clear.
Yes, it's clear now.
Okay, so sorry about that. I really didn't realize that I wrote trade-in value, and that maybe it would throw some of you off, but it's in the past now. So I have 6 minutes. I don't think I'm going to get to my quiz question, or maybe I'll do my quiz question after I finish this, even if I take a little bit longer, and you can leave if you want to. Let me. Oh, taxes. Yeah, so I skipped over. Well, I'm going to be quick, unfortunately, Mohammed, but you can ask me very specific questions if you have some. So makers is what we use for taxes, for depreciation, right? It just gives us a standard way of doing things, right? It uses a table. If you have personal property, remember for personal property, we said this is anything that can be moved, right? So anything pretty much except buildings, right? Pretty much. And the way we do it is using the table, the blue table that I'm going to show you in 2 slides. There's a half-year convention, right, which basically means you claim half of the depreciation in the first year, full depreciations values for the next few years, whatever number of years you have, and then half of the depreciation in the last year. So you can see kind of the first year's depreciation is kind of split over 2 halves. I guess you can think about it that way. And also, we always assume a 0 salvage value. So if I give you a salvage value in the problem, but you know you need to use makers, the salvage value is pretty much irrelevant. And that was, I think, in the homework some of you were asking, like, which one should I use? Well, always with makers, you assume a 0 salvage value. Just use the table. I mean, the table already assumes this table here. Right? If you compute these percentages, it's assuming that you depreciate. I mean, these add up to 100%. So this means you're depreciating, or you're distributing the entire cost of the asset, and therefore you have no salvage value, right? You're just going to take your I, your investment cost, and you're going to depreciate that. Okay, there's no S. What about real property? Well, these are buildings, pretty much. And here, we don't use a table, but it's very easy because we use the straight line approach, which is very easy. As hopefully you remember, the formula looks like this. And this is going to be the same for every year. This is the amount of depreciation in every year. The complicating thing about this is the mid-month convention, which is very similar to the half-year convention. But here we're saying basically if you bought the building on day 1 of a month, we're going to treat it as if you bought it on day 15 for tax purposes. This is just how they do things. Right? Also, we have a 0 salvage value. So this is important to know because here you actually have to input S yourself. And so you have to know that S should be 0 in this case because we're using makers for buildings, for real property. This is the table for personal property. And remember what I said, you just take I and you just multiply by the percentage in each year. That's all you need to do. And that gives you the depreciation in each year. There's one complicating factor that will come later, which is when you sell the machine before the end of its recovery period. In that case, you have to do some other things. But generally speaking, as you see in this example, S is 0. I know that the cost of my asset is 10,000, so I'll just take 10,000 it's a 5 years maker's property. So I will go back to the table, 5 years, right? Take these percentages, copy them, which is what you see here, and just multiply I by each one of them, right? I by 20% gives me this value, by 32% gives me this value, and so on. And we already said that these percentages have the half-year convention built in, so you don't need to worry about that. Okay, then we talked about this example. Oh, here we have a building example, right? And here we said we have to worry about the mid-month convention. And so here, let's see. So the building is purchased on May 1st for this amount. And remember, one other key thing that we said here is that land cannot be depreciated. This is very important. So if I tell you that this 100% consists of 80 for the cost of the building and 20 for the land, you do not depreciate this 20. You just take the cost of the building, and that's what you depreciate. Then the building is sold 9 years later on October 1st. And here's where the mid-month convention comes into play. We're going to say, let's assume that it was bought on May 15th, because we have the mid-month convention. Let's assume it is sold on October 15th, because again, we have the mid-month convention. Right? And it's telling you he sold it for this amount. As you will see, this amount is irrelevant, because, I mean, we assume a salvage value of 0. That's very important. And we're using makers. Okay, so in order to compute this, I need to use the straight line depreciation approach, which is I minus S. Remember, S is 0, divided by N. N is actually given in the makers table, but in this one here. N is 27.5 years for real property, for residential rental properties, which is, I mean, this was a residential rental property in the example, as you see here. So use that N. Do not use the N of ownership, right? He owned the building for 9 years. Don't use that N. You, again, because this is makers, we go back to references. We go back to tables, which are published by the IRS. So it says 27.5. So that's what I use, and that's what you see here. So this fraction should be clear. But then I need to address the mid-month convention. And so the first year, I bought the building, or this guy bought the building in May 15th. So he owned the building in that year for 7.5 over 12% of the year, right? 7.5 months out of 12 months of the year. So if you start from May 15th, right, you compute the number of months, it will be 7.5. In the year in which he sold it, he started from the beginning, and he sold it in October. So he owned it for 9 full months until the end of September, and then the half month in October because of the half month convention. And therefore, I have to multiply by 9.5 divided by 12. Only in year 10 and in year 1. All the middle years, I can just apply this formula as is, and I'm good to go. Okay, so I'm out of time now. Hamad, if you have specific questions, let me know. I'll go over them with you if you have time. I want to be sure to answer them. You guys are free to leave if you want to. I mean, oh, gains. Okay, yeah, so I'll skip to gains. Hopefully I didn't waste time covering this, since maybe it was so easy.
Doctor?
Yes.
After this class, you have office hour?
So next class, yeah, after the quiz, I'll be around for office hours. If you want to ask me, then that's fine.
Okay.
Khalid?
دكتور الكلاس الجاي بعد الكويز لو نسوي نفس الطريقة بعد يعني اللي بيمشي يمشي اللي بيجلس تكمل مراجعة من 9 وطالع يعني.
I have no problem with that. Yeah, maybe I can do that, and then I can just stop here and
ولا إذا محمد طبعا
continue.
يعني عنده سؤال الحين ويبغى الجيمز مو مشكلة يعني طبعا هذا بينك وبينه لكن أتكلم للعامة.
Yeah.
إن نكمل 9 من الكلاس الجاي يكون اللي يبغى يطلع واللي يبغى يجلس يكمل 9 زي مراجعة اليوم يعني يجلس.
I have no issues with that. That sounds like a good idea to me, especially since I'm not done. I mean, I didn't even. Maybe I'm halfway through, but the remainder of 9 is very important, and also the quiz question is very important. So yeah, I think that's a good idea. Yeah, maybe I'll just do that. So up to you guys. If you want to ask me questions now, I'll be here for a few minutes. Other than that, maybe I'll just stop recording, and we'll pick this up next class after the quiz.